Okay, let me explain a little bit about R and RStudio, and I hope I'm assuming everybody's got a computer and that you're allowed to install stuff on it. There's a chance that something doesn't work, okay? And if that's the case, contact me and I might be able to get you set up with this browser version of RStudio, but really try to get it working on your thing. Okay, so there's two pieces of software that you're gonna have to install. Okay, one is called R. Okay, and you know when you deal with statistical software, there's all sorts of options. There's Stata, there's SPSS, there's SAS, and then there's R. Okay, and I chose R because it's free, right? And it's popular enough in the academic world. When you go into the field and stuff, they might use R, they might not. Okay, um, but you know once you learn some basics in one statistical package, it's pretty similar in other things. Okay, all the commands change and things like that, but you know you get a manual, you read through it, you'll get the hang of it. Okay. Okay, so anyway, you go to Google, you type in R, and then the first thing that pops up should be the R project for statistical computing, okay? If for some reason your R, Google doesn't give you that, you can type in r-project.org, okay? But it should be your first hit, okay? You go there, and you get this website. It's a little bit ugly. And then you're going to download R, okay? And they call it CRAN, Comprehensive R something network. There. And then this is all worldwide locations, okay? Probably pick the UCLA one, but you know, you can pick any of these servers and it'll work just fine. That's the magic of the internet. But probably the UCLA server will give you the best speeds and lowest latency and things like that. Okay. All right, and then anyway, you download the one for Mac or Windows, depending on what computer you're using. Okay. Simple enough. So you click this, and it says you download this one. So you click this one, and then it says you click this one. Okay. Simple as that. Okay. You should be able to download and install that, and it should work okay. All right. There's something you can install on top of R called RStudio. Okay. So when you open up R, it's this very plain interface. Okay. It looks like you're typing into a old shell prompt. Okay. There's something called RStudio, which just makes it a little bit prettier. Okay, and it adds some buttons and things for common things, which I like. Okay, but some people have reported problems using RStudio, like it didn't like their computer. If you can't get RStudio working, that's okay. If you can get basic R working, then you can do everything that I'm asking you. Okay, RStudio just makes a few things a little bit easier, a little bit nicer to do. Okay, but you have to install the R first, and then you install RStudio on top, and that just adds the little bells and whistles. Okay, so you just go type in RStudio into Google. You go, okay, or you can click the download one. All right, and just say download now, and it will try to figure out what computer you're using. Okay, you get the desktop version. I guess you can get the server version, but just get the desktop one, and it'll figure out what computer type you're using, and you download that and you install it. Okay, should work no problem. And when you open it up, okay, you start up RStudio. It should look something like this. Okay, I blew up my text so it's easier for you guys to see. your text will not be this huge. Okay, and this is just legal gibberish that says like, you downloaded it for free. If you can't get it to work, don't complain. That's pretty much what it says. Okay, so you can use this. Can you guys see this lower line here? Or do I need to? Maybe I'll shrink my window a little bit, bring up the bottom. Okay, is that better for those of you? All right, and you can use it as a calculator. You'd say, you know, what is 3 plus 7? Okay, and if I hit enter, it tells me the answer is 10. Okay, it gives me this bracket 1. All right, and that's because R is intended to handle lots of data, and so sometimes it returns multiple numbers at the same time, and this just means your answer, the first element in your answer, that's what this bracket 1 means, is 10. Okay, the first element in your answer is 10. Okay, let me just give you a demonstration. We can say make a sequence from 1 to 100. Okay, and shorthand is 1:100. Okay, and let's see, this text is too big. Let's just do 1 through 30, or 1 through 20. Okay, so 1 through 20. This is the sequence. Okay, it says the very first element in your answer is 1, and the 9th element is 9, and the 17th element is 17. That's what those brackets mean. Okay, and then you can say, well, you know, if you hit the up arrow on your keyboard, it gives you the last thing you typed in, and you can tell R to do stuff. You can say take that sequence 1 through 20, and to each number I want you to multiply it by 1.1. Okay, and here's your answers. Okay, it says if you multiply, you know, the first element is 1.1, and etc., etc., etc. Okay. All right, so you can explore calculations and basic operations. Okay, if all of these things, you can just do. You can do R basic operators, okay, and that will tell you just things like addition, subtraction, and stuff, and division with remainders and stuff like that. Okay, so all of these things I would just, if anything, if you're gonna write notes, just write the notes of what to search for in Google. Okay, because most of your work, if you get stuck on something, you're gonna Google your answer 90% of the time. Okay, or Bing here. You can also do ask for help on any kind of function that I'm gonna show to you. Okay, so one thing we learned today is so your very first lab this week is going to be really easy. Maybe I should make it tougher because people complained the next week was way too hard. So okay, it's a balancing act. Okay, so I'm going to teach you just a few basic operations. Okay, so one is R has a built-in normal table. Okay. And the normal table, just like this, the function that you use for that is called p-norm. Okay, the P stands for probability. Give me the probability from the normal table. And if you type in the number, like if I type in the number 0, okay, what R is going to tell me is it's going to give me what's the probability of having a z-score less than 0. Okay, so if I hit enter, what should my result be? 0.5. And indeed it is. Okay, and I can do p-norm 0.01. Okay, and from our normal table, we see that the answer should be what? 0.5040. Okay, when I do that, okay? R actually tells me it's 0.5039894, okay? So R has several more decimals of precision, okay? And whereas our normal table can only go out to the hundredths place, R can go out to the, you know, whatever place you want. Okay, it's a very precise calculator. Okay, if you have these very precise z-scores. Okay. So you can do that. You can also say, all right, if I type in, we say, well, what percentage of women are shorter than 67 inches? Okay. So one way we could answer that is we could do 67 minus the mean divided by the standard deviation to get our z-score. Okay. Or we could ask R, and we could say, I'm going to give you 67, and I'm going to tell you that the mean is 64.5, and the standard deviation is equal to 3. Okay? So these are arguments that the function accepts, and then it does the math for you. Okay? It says, okay, well, you gave me this number 67, and you also gave me a mean and a standard deviation, and so I've calculated that probability for you. Yes?
Are there special like spacing rules that will throw it up?
It's case sensitive, and whether you put a space or not doesn't matter. Okay? But you do need to put commas between your arguments. Okay, you got to put commas there. But you know, you could put a space here between the equals, and it's all the same. Okay. If you're not sure what you can do, you can put question mark p norm. Okay, and that asks R. I need help on p norm. Okay, and you can see that it pops up over here in help. Okay, and you could do question mark p norm there, or you can type in p norm over here. You can pop this out into a new window, okay? And it says the normal distribution, okay? And then there's P norm and Q norm, and then there's also D norm and R norm. But we will ignore D norm and R norm for now, okay? So P norm, it says you can specify the mean and the standard deviation. And with this mean equals 0 and SD equals 1 is that if you don't tell me a mean and you don't tell me a standard deviation, as R, I'm going to assume you mean mean is 0 and standard deviation equals 1, okay, which is what the normal table is there. But you can say, well, override, I'm telling you the mean is this, okay? And in fact, as long as you provide these things in this order, mean and then standard deviation, you can do, oops, typed in the wrong spot. You can do P norm 67, comma 64.5, comma 3, okay? And because, like, oh no. Because it has this order, mean, you know, the first thing, then the mean, then the standard deviation, because it accepts those things and those, it's expecting it that order, it's going to process it like that. Okay.
How does it know if it's a Z scale or a Y scale?
What do you mean?
I mean, do I have to convert to Z scale first before it's really there, or?
Yeah. So.
If I enter a number, how does it know which scale I'm using?
Because so if you don't give it anything else, it's assuming Z, which is mean 0, standard deviation 1. Okay. If you give it anything else, it's going to use that. It's going to assume these are the mean and standard deviation. Okay. On the other hand, there's Q norm. Okay. Q norm is just the reverse of P norm. So I said, you know, how tall is a woman in the 20th percentile? Okay. In this case, you do Q norm 0.20. Okay. And when you do Q norm 0.20, it's going to give me, if I don't specify a mean and standard deviation, it'll tell me the Z score that gives me 0.20 is negative 0.8416.212. Okay, when you guys looked it up, you just saw negative 0.84. Okay, and then if you say, well, don't just give me the z-score, I'm going to tell you that the mean is 64.5 and the standard deviation is 3. Then it says, okay, I'll take that. And then it says, okay, well, the woman in the 20th percentile is 61.975 inches tall. Okay, so 62 inches, which is what we got when we did it in class, right? Okay, so that's not too bad, right? So that's P norm and Q norm, okay? And then we have the binomial distribution, okay? And the function we will use is d binom, okay? So what P does, so and let me just explain, alright? So P norm is, if I give you a number, you tell me everything, the area to the left. Q norm is I'm giving you the area, you tell me what value. And D norm, which we don't use, is I'm giving you a exact number and you tell me the probability of getting that exact value. Okay, but it's not really a probability, it's called a density, alright? And it doesn't quite work for, I mean, there is a meaning for continuous distributions, but it doesn't have a practical thing, okay? However, for discrete distributions, the density does have a meaning, okay? So D binom tells you what is the probability of getting this exact value. So it's, if I flip a coin 4 times, what's the probability, or if I flip a coin, 4 times, what's the probability that it lands heads exactly twice? Okay? Is that right? N equals 4 and P equals 0.5. So I messed something up. Okay. See, now I have to ask for help. So D binom, size. It's not N, but size. Okay. X size of probability. Okay. So here I say D binom size equals 4 and probability or P is fine. Okay. So this is, if I flip a coin 4 times and the probability it lands heads is 0.5, what's the probability I get exactly 2 heads? That's D binom. Okay.
And essentially you can still put the 2, 4, 0.5 and it'll still be the
Yes,
same.
I
Okay.
can do 2, 4, 0.5, and it will give me that, okay? I could say, well, what if I flip a coin 40 times, what's the probability I get exactly 20 heads, okay? And it will tell you right there. That's 40 flips, 20, this and that, okay? So, our last question was, what's the probability I get 28 or more? Okay, so I could do D binom 28, D binom 29, and you can see this is still going to be a pain to add up, right? Well, one thing I can do is I can do 28 through 40, okay? And this is just shorthand for saying all the numbers 28, 29, 30, all the way up to 40, okay? And so when I ask R to do this, it's going to spit out a whole bunch of numbers. It's going to say, this is of getting 28 heads, 29 heads, 30, 31, 32, 33, all the way up to 40 heads, okay? And we can see that this matches this. It's just in scientific notation. Are you guys okay reading scientific notation? E equals E minus O3 just means move the decimal 1, 2, 3 spaces over, right? 1, 2, 3. Okay.
Now, does that incorporate the continuity, what is it?
You know, there's
correction?
no continuity correction here because we're not, the continuity correction only applies when we are approximating a discrete with a continuous. But here we're just finding the values of the binomial distribution itself. Okay, so there's no approximations. These are exact values from the binomial. Yeah.
Why is it that when you did D binom 20, 40, 0.5, it said 12%?
That's the answer.
So
If you flip a coin 40 times, the probability you get 20 heads is 12%. That's it. Yes.
If you were to plug this in with your calculator, could we do 28 through 40, or we have to do it individually?
I guess it depends what kind of calculator you have. If you have a regular calculator, you're gonna have to do each one individually. Okay. That one might be able to do. I'm not quite sure. Okay. But what we wanted was what's the probability of getting all of this. Okay. So there's a function called sum. Okay, and in sum you can just say add up the numbers 1 through 3, and it will add them up 1, 2, and 3 and give you 6. Okay. Well, the results of D binom 28 through 40 is actually these 13 numbers. Okay. So I could just say take these 13 numbers and sum them up. Okay. So when you see this thing, just imagine or just know that this represents these 13 numbers. Okay. So what I'm going to do is I'm going to just say take this and sum everything, all the numbers that are output here. Okay. So it's just going to take these 13 numbers and sum them up. And I hit enter, and the answer is 0.00829. Okay. Is that what we got when we did our we got 0.0089. Okay. So the exact answer was 0.0083, and our normal approximation was 0.0089. Okay. So that's off by a little bit, but that's what we have. Okay. So that's those are just a few functions that you can do with R. Next week, when we use R, we're going to learn how to import data and do some things based on there. This week, you're just going to use R as kind of this stats calculator, probability calculator. So this lab is very easy. I don't know. Maybe I should work out a balance between this week's and next week's.
I thought the lab also says asking to import data from like a world height.
Did I
race,
do that? Okay. Maybe I did actually modify that. Let me just check. I forgot.
But you do have a video online to show people how to do that. So.
Oh, okay. I did. Oh yeah, there is. Okay. So do that. Does this thing work?
It does.
It does. Okay, great. So, yes. Okay. So you can import data in step 3, and there's a few functions that when you have a data set, you can create histograms and box plots and all that. I forgot I had modified the assignment. Okay. Kotlin slightly unprepared for this. Okay. Well, I've linked to a couple resources here. Okay, so as you're getting started with R, okay, so if you've never really dealt with a computer programming language, if you've never taken a programming class, the thing to know is that computers are very, very, very literal. Okay, you type in one character wrong, and it won't know what to do. Okay, you put a comma in the wrong space. It doesn't know what to do. You put things in the wrong place. You capitalize wrong. It gets confused. Okay. People are smart. You use the wrong word in a sentence, they can still figure out what you're talking about. Computers are not that way. You gotta do things exactly as they're going. So, if you're typing something in and you get an error message, okay, go back and just check every little character that you're typing in, okay? If you get an error message, don't keep going thinking that you can power through it, okay? You've got to take care of the error message right away so that your later steps, the problem doesn't propagate. Okay? So, you know, if it's frustrating, okay, that's all right. You can post questions on the Facebook group. We'll try to help each other out. Okay. It should be okay. But if it's not,